So welcome back, everyone. As our event starts to draw to a close, we do have one more fascinating panel entitled Synthesizing the NAS, Aviation's New Frontier and Our Existing System. Pretty sure that's going to capture your interest and bring our close to this event. Moderating this panel is someone who has dedicated her life to advocating on behalf of aviation safety professionals, both domestically and internationally. It is my honor to introduce IFATCA's Executive Vice President for the Americas region and my predecessor as NATCA's Executive Vice President, my longtime friend, Trish Gilbert.
Thank you so much. That was very nice. I missed you all, your smiling faces and hospitality suite conversations that we've had for many years. But it's great to be on stage to moderate this next panel. The previous panel had a lot of good things for us to think about and kicked us off in a very nice way for the conversation that I know we're all going to have and should be having and should have been having already, but we need to continue to do so because it is going to be significantly different if we're not careful. And we need to be careful in making sure that the system is safe and seamless. More than 45,000 flights safely fly through the United States each day. With the inclusion of millions of new types of uncrewed aircraft systems or remotely piloted systems, how will full integration be safe and hopefully seamless? Along with these new entrants and our current legacy users, and you, the women and men that provide guidance and separation in controlled airspace, have all along recognized the importance of safe and efficient integration into non-segregated airspace and at aerodromes, whether the aircraft has a pilot on board, is remotely piloted, fully autonomous, or a combination thereof. To have this very important discussion, I would like to bring on stage our expert panel. First, Andy Cebula with Airlines for America. He's the VP for Air Traffic Management and Operations. Parimal Kopardekar, or PK, which is what I'm going to use from now on, because NASA likes their acronyms, Director of NASA Aeronautics and Research Institute. Our own Jimmy Smith, the NATCA National UAS Representative. And finally, Wendy O'Connor, FAA AJT-3. So PK wasn't with us before just a couple minutes ago, so he didn't get to witness the panel before us. But I kind of filled him in that there was quite an interesting conversation. And what I pulled from that last panel is about 6 pages of questions that came to the group. A lot of them have a lot to do with integration, so we're going to try and get to those and answer the questions. But the conversation, as I mentioned earlier, is going to continue. As air traffic controllers and other aviation safety professionals, safety is in our DNA. That's what we're all about. The rest of the industry right there along with us. So with this new technology and this discussion of not just accommodation and segregation of these new entrants, now the discussion's very robust on full integration and what that might look like. So PK, I have the first question for you. And it's a lengthy one, and we already discussed that we're going to have a dialogue between all the panelists, so it's not going to be a question and we're going to talk together about this. But we're going to start with the first one, PK. This technology has the potential for significant economic and societal and environmental benefits. There's no debate there. And as the pace of innovation is rapid, it has seen remarkable technological improvement in terms of software and hardware components, whether it's in the aircraft itself, at the remotely piloted stations that will control them, detect and avoid systems, command and control, C2 link. So the integration to safely put these aircraft with our legacy users in the non-segregated environment and at aerodromes, they must comply with communications, navigational, and surveillance requirements. CNS is what they call it because we got a lot of acronyms, we got to do that, right? Are there going to be areas where that is not achievable due to the unique design of these aircraft, the flight characteristics of them, or the lack of a pilot on board?
Yeah, it's a great question. Really very interesting question in terms of the potential of the industry as well as the new technology and how do we enable them. So this is really fundamental to basically enabling a safe, scalable integration. So we are after two things. One is safe integration to begin with, and then it has to scale to get the benefit to the society. You know, my personal long-term dream is every zip code in the globe should be reached by some form of aviation to get them the value of aviations, by drones, by eVTOLs, and later on many other types of things. But in order to get there, we have to make sure that the services and the tracking of the vehicles and communication to them is always ubiquitous and possible. We did the drone testing, and we did series of tests, what we call technology capability level, all the way from remote areas to the urban areas. And we discovered that there are places where the communication is not always reliable, or the GPS is not always reliable. So we had to have basically capabilities in place that will enable these operations in a manner that you leverage the new types of communications that are coming out, whether it's 5G, whether it's different types of satellite communications, different bands, and so on and so forth, as well as basically the triangulation of the vehicle so that localization is really good with or without GPS. So the parts that you talk about, CNS, the navigation becomes very important. How do we get there? In lots of parts of the United States and all over the world, the ANSPs provide the infrastructure. In areas where the drones will operate, or eventually some other types of eVTOLs will operate, that infrastructure is not always existing because we didn't need it. For example, weather information is part of that. When that infrastructure doesn't exist, but we need to have that capabilities so that we have safe integration, we are looking at a paradigm where can we set requirements and third parties can provide that structure within the regulatory authority of FAA. So FAA has to approve it, obviously, but can we say that in order to operate in Reno, we did some tests here, you must have these following characteristics of your communication, or you must have a navigation capability with or without GPS, and there are different alternative schemes for that. You must have other forms of basically management for contingencies. For example, what happens if there is a bird strike, or what happens when there is comlink failure? All of those need to be basically taken into account, and our tests indicate that basically if we start to migrate to a digital characterization of the trajectories and the strategic basically deconfliction across a number of vehicles, because it's not going to be just the one operator that will operate in the airspace. There will be many others in the same airspace at the same time. So how do you deconflict them? Possibly strategic deconfliction to start with and detect and avoid, as you pointed out. For tactical deconfliction, that's one. So digitization, cooperation across operators where they share and care about each other. Then third part is this kind of service-oriented architecture where the services are subscribed by or possibly provided by third parties or provided by local regions, as some other countries are trying to do when the services don't exist. And then we are very keen on making sure the integration occurs safe and it's interoperable. We do not want to overload the air traffic control system. As you said, the current system is one of the safest, and the order of magnitude of these small drones where the pilot is not on board is order of millions. And in order to accommodate them, basically, can we change to a paradigm where air traffic controllers and control system can say, here are the places where you shouldn't go, and instead of basically waiting for air traffic controller to watch every little drone and give clearance. So change the paradigm to management by exception, so give them strategic guidance as to where the airspace is, like we have been doing with lands under FAA. So I'll summarize it. In order to get to that communication, navigation, surveillance, if we can characterize all the services needed for safe integration, see where those services exist, and if they don't exist, can we get third parties under the FAA's regulatory authority to say, if you meet these service requirements, you can also offer those services, and the operators possibly will subscribe to those.
So clearly, you belong at NASA. I want to bring that down to my level, because I am not a rocket scientist or a NASA researcher. But I did stay at Bally's last night. So I just want to make sure that what I think I'm hearing from you is that, and Brian said it yesterday on a different panel, which is automation is going to be key to the safe integration. That scares me a little bit, because what I hear, and so let's talk about that, Jimmy, is automation going to replace air traffic controllers in separating the multitude of different types of aircraft that will be in the system? Right now, under Lance and UTM, that's occurring to one level. What's going to happen when they integrate with legacy users? Is that the goal, that we become monitors instead of controllers?
No, so automation is going to be a great thing for air traffic. I mean, it's shown how air traffic has grown to this point that automation does a good thing, but it doesn't replace us, right? And I don't think it ever can, not unless AI becomes something anytime soon, which I don't think so. I don't think Terminators will be walking around and doing things. So it is there to assist us, but it's not the silver bullet to integration. So I think automation is one piece to it. UTM can be a piece to it, but I think air traffic and the 20,000 aviation professionals represented by NATCA are a huge piece in that. We integrate all different types of airframes today, from jets, shuttle launches, above 60,000 feet. I mean, the helicopters. We already do this. We're good at it. It's our bread and butter, and we care about it. That's why there's so many people here. So I think automation does have a big piece in it, but I would hesitate to say that is a silver bullet that's going to move everything forward. There's a lot of talk about all these different things that we're going to improve and we're going to update and whatnot. I think hearing the lack of, hey, air traffic needs to be updated, and let's give our people the tools and the training they need to move this stuff forward, I think that conversation needs to happen some more.
So, I mean, we did have that panel yesterday, that high-level view that Paul, well, no, it was the one before, Tom, and some of the, Leidos and Raytheon were on the panel about the pace at which technology can be implemented in the FAA, 2 to 3 years. We have clearly a strain already, or challenges already, on implementing new technologies that we need today, not new entrants, but new technologies we need now. We have aging infrastructure. Some of our towers and radar rooms are very, very old. So Andy, from the airline perspective, how do you see this fitting in with the current challenges that we face? I haven't even talked about staffing, which is not just a US thing. We have shortage of air traffic controllers globally, as well as many other aviation professionals. How do you see those challenges of today accommodating these new entrants and their needs for tomorrow?
Yeah, so the 10 major airlines that the Airlines for America represents, first of all, thanks you for all of the work that you do. We certainly are emerging from an incredibly challenging summer and spring, but really working together, I think we're going to be able to plan and work for a better future, all in the wake of the demand that the passengers are putting on wanting to travel, which is a great thing to have. So it's really important, as we talk about new entrants, to look at where we are right now, which is the fact that we're coming at a point where there hasn't been a lot of modernization in the last couple of years. The FAA is kind of over budget and behind schedule, and so it is really important that we work on, from our perspective, focusing on getting the programs that are critical, either through the paths that we've laid out for them, like Datacom, or looking at something like Terminal Flight Data Manager that has a lot of capabilities that are really important to us, and fielding it more quickly. I do think that when you look at the demands, in particular for the airlines, it would probably be in the air traffic control system for controlled airspace, it's probably going to be more AAM than UAS that we'll be concerned about. And so as they're looking at what their demands are, what their expectations are, I think that's going to be the key, is when and to what extent. But the projections right now would have them coming into the air traffic control system similar to the way that helicopters are treated today. And then the scale is really going to be determined by the business case.
So Jimmy, for you, and you're next, Wendy. AAM going to be first, which is referred to as air taxis, our new taxis with the eVTOL. We've heard conversations about they're going to just fly through corridors and we're going to separate from the corridors in airspace. Is that what we're going to look at, Jimmy, or is it something different or a combination?
So,
and then Wendy, for you as well.
So as far as I'm concerned, like, I understand there's a brainstorming, right? So at first they say there's no such thing as a bad idea, which we can talk about that later. But when you start to break down what a corridor actually means, and on paper it sounds great. Oh, it'll be so easy. I'll fly from LAX through this corridor, go out to Disneyland, enjoy the day, and then go back. But then once you start to break down what does that really mean, if a controller's not talking to this one aircraft, well, then you now have segregated airspace. Mm-hmm. Now, segregation is not integration. So if I can only talk to one, then I have to move everybody around that corridor. And then let's break it down even further. Weather happens. There's all kinds of medevac helicopters coming in, doing all that stuff. So, and then a corridor, and if that was the case, how many people would love to have their own corridor through Bravo? Sweet. I'd never have to take any delay whatsoever. But clearly that is not a model that is scalable, because if it was, it would be there now. So we have to be good stewards of the airspace. AAM has a right to the airspace, just like an airline has a right, just like your Cirrus, your Skyhawk, and everybody else. So, and that's why we exist. We are there to help that come together. So the corridor thing, I don't see it being I hate to keep saying the same thing over and over again, the silver bullet, but a corridor concept, in my opinion, as it exists today, what we talk about, I don't see that being what's going to get us there. I think air traffic controllers getting the training that they need, the equipment they need. You know, let's look at some of the rules. These AAM aircraft, they can do a lot of different things. They don't need a 10,000 foot piece of concrete to put this down on. There are different things that they are capable of. Let's look at the rules. Let's see what we can massage. Let's see what we can train people to do, and maybe increase access to the airports, without delaying traditional or, the current users of the NAS. And I think that's more where we should be looking, not carving stuff out just for one user.
And Wendy, feel free to answer that, but I want to add on to your question. Let's pretend that we don't have these financing challenges that Paul's panel talked about yesterday, or the time constraints that it takes, to get a funding and then implementation of new technologies. And we had enough controllers to provide the service that we all know that we can. What would integration look like? Full integration, not corridors, not UTM and accommodation, full integration. What kind of equipment will we need on board these aircraft at the pilot stations to be able for them to basically operate as legacy users do? That's the only way we're going to have a seamless integration. What would we need?
Oh, wow. Talk about an easy one. And oh, what a perfect world that would be. That would just be the ultimate if we had all of that in place. I think in order to have that integration in place, we would have the aircraft have their DAA, detection and avoid equipment on board. On all of the aircraft, so that we knew that it was a little bit safer and they could separate from other aircraft. As we heard in the previous panel, some of the other gentlemen that were up here talk about, those aircraft would give way to our manned aircraft, and they would need the equipment on board, and they would need the trained pilots on board. I think we would need to have some automation in place for awareness for our controller workforce. What that would look like, I'm not sure. We're still in the planning phase, as they said in the previous panel. Crawl, walk, run. We're in the beginning of that crawl stage, in my opinion, and let me know if you disagree, but I think we're crawling right now. But as long as we are talking and having these conversations, and we're working with some of the industry folks and within our organizations, and of course our NATCA folks are there with us, working with the controller workforce to figure this out, I think we can get to the integration piece that we need to. The acquisition process and the funding process is a whole nother situation, which was on a panel yesterday, but we're going to work through that. We're trying to work through that. To your previous comments, Andy, we are modernizing the NAS. We are operationalizing next gen as much as we possibly can. We've had a tough couple of years, as everyone knows, and we haven't been able to do nearly as much as we want, but we certainly want to. So with that, I think I answered that question.
Yeah, if I could.
Go ahead, Andy.
Yeah, I think when we, and my focus is on AAM so much because there are several of our members that have made investments in AAM, and it looks like that at least one of the applications would be transporting people to an air carrier airport to go on a flight somewhere. So you're using it as a kind of a connecting type service in metropolitan areas. So let's just take that scenario for a moment. In that kind of a scenario, the expectation that I would have for the aircraft is that it's going to have the full suite of avionics that any other user of the NAS right now that flies in controlled airspace in VFR and IFR conditions would need to have. And then as far as the air traffic control system, I mean, they would be flying in controlled airspace, really, especially if they're in metro areas, for the most part, So I think that the expectation, and again, looking at this, like let's say through the end of the decade, so something like that is just you got to throw it out there as a rough order of magnitude. That would be the kind of expectation that I would think we would be having for what the NAS can provide to accommodate this new user.
So there is testing being done with full integration at certain parts in the country. We had a panel up here a couple of years ago, well now if you add COVID, more than a couple of years ago, about the testing with the MQ-9 at Syracuse, and where you have they mentioned it on the previous panel at Concord, and just found out yesterday, University of Alaska is doing some testing with the controllers up at Fairbanks, not a lot, but they're just starting that. So. And there's a lot to be found from testing, but I think, with the proper principles and assumption on integration, laying out those expectations for these new entrants that aren't legacy users are going to be key, because the expectation would be they need to operate just like legacy users. They need to be able to detect and avoid, because they won't be able to see and avoid. They need to be able to take ATC clearances and be separated by air traffic control. So if they're flying in Class B, they need to be equipped to fly in Class B airspace, no different than a GA pilot would have to be. So my question is, what are we learning from this testing? And PK, you're probably the best, or Jimmy, what are we learning from this testing? X-Wing, they had a lot of good things to say about their testing and their capabilities. I do sit on the RPAS panel at ICAO, and it does seem that not every business case is going to come across the line with cameras on the aircraft, with the most robust detect and avoid. There's still a lot of conversations about lost comm, but not in these cases with these aircraft. It's just not lost comm, it's command and control. You lose the C2 link, you lose the ability to control the aircraft. Is that okay? They say yes, because they can program these aircraft to become autonomous at that point and go to their destination airport or return back to base, whatever the aircraft is programmed to do. So with all of these things, saying what else are we learning from these tests, and when do we see this kind of thing expanding more to more airports and affecting more of our air traffic controllers? More tests, more integration. Not full integration,
Yeah,
just
sure.
testing.
No, so clearly, I mean, I completely agree with Wendy and Jimmy both that we don't really know yet if corridors is the only solution. Research is underway, so we don't necessarily know for sure, 100%, that corridors is the way to go. The two principles that and actually I learned them by doing years of air traffic control simulations with you all, starting with Cleveland Center back in 1993, is flexibility where possible and structure where it's necessary. We don't necessarily need to have structures everywhere, but there may be places where, because of the complexity of the traffic and different things that happen in the airspace, you may need a structure. We don't know that. That's a very basically localized thing. So that's my fundamental principle, is as much flexibility as possible and only structures where it's necessary, like corridor. Second is integration where possible and segregation where it's absolutely necessary. We don't necessarily want to go in with the attitude that we have to segregate everything, but we try to integrate as much as possible, because that's the only way we can scale and harmonize airspace operations. So that's another fundamental principle. Now UTM, as you pointed out, because it's 400 feet and below, and we started off with Class G airspace, it could be basically tested new things. So your point about testing things and learning from simulations and gives a way for us to understand. After the 4 major tests we did at the national level with all the FAA test sites, we learned a number of things in testing. As an example, the drone operators were using different altitude schemes. Some of them were using AGL, some of them were using MSL, some of them were using AGL, but from where the drone took off. Some of them were using AGL where the ground control station is. Some of them were using AGL where the drone was. As a result, what would happen is you say, oh, I'm 20 feet above AGL, but you are in the bush because that was a sloping thing, right? So you have to harmonize. Okay, so now we learn. Okay, so we need to harmonize how basically we need to use a common referencing scheme for all of these entrants. That's different. Manned aviation learned that a long time ago. We use MSL, right? So that's sort of the...
Thankfully.
Yeah. So that's one simple example, as it may sound, but I think these are the things that testing reveals. Other example is winds. We were actually, I'll give, so the winds is an interesting example. When we had updrafts, so fixed wing drones would go up and down 50 to 100 feet, and because the draft, and that has implications on how close you let them fly with anybody else, right? So that's like, oh, that's interesting insight. Without testing, we would not know that. We basically have this, says battery life, 45 minutes, this, that, another, but is that real? So third example is we were doing testing in Reno, FAA test site, which is 5,080 feet, I think. So the air is a little bit thinner than sea level, hot day, 98 degrees, and a headwind. The battery life drops from 45 minutes to 1/3 of a mile, literally. That happened. Well, we learned that because this combination of these factors have influence on what actually you can do. So all these things wouldn't have been learned without the right type of testing. So NASA, we believe in a lot of testing, simulations for procedures, the information needs, the requirements, working very closely with FAA and next-gen ATO on information architecture and all of that. For sure, we had to do those simulations, tabletop exercises, but the testing we do uncovers fundamental things that sometimes we miss in simulations, and that was really eye-opening. And as a result, we expanded the testing paradigm of the unmanned aircraft system traffic management from technology capability level 1, 2, 3, 4. Now we are doing national campaign testing for the advanced air mobility. So we're testing the eVTOLs and basically STOLs to say how would they operate? What would be the impact on them? What if they had to get service for navigation because GPS is not reliable? How would that work? What would be the performance requirements on those? That's the kind of stuff. It's really interesting and exciting that you uncover through series of testing.
So, the last panel surely left a exciting vibe for the room. And I thought, oh, I'm going to get up there, I'm going to be negative Nelly. So let's just answer this question as truthfully and as robustly as you can. We have financing issues, we have staffing challenges, we have deployment delays. As good as we are, there's always also these external things that prevent us. And we have the safest, most efficient system in the world with legacy users. And we're accommodating uncrewed aircraft in Lance and expanding to UTM. Why? Why integrate at all? If you want to answer that, why should we do what we need to do to fully integrate?
And I'll take that. I think the only way that you can ensure the safety continues in the NAS is you don't want to push these people away. It's great for the economy, it's great for the country, it's great for business, and again, we're stewards of the airspace, and as an organization, in my opinion, we don't shy away from that tough conversation. We don't shy away from that problem that has presented itself. There are so many things that has happened just in a short amount of time that I've been sitting behind the scope that we have adapted and we have overcome those challenges, and that's what we are great at. These people, this is their airspace too. They have every right to be in it, and it's our job to make sure that we help them come into this airspace safely. So I think that's why we need to integrate them.
And Wendy, when you answer that question, can you talk about what's happening? Obviously, this is not just a United States situation. It's happening around the world. Integration, accommodation, these discussions. Certainly ICAO, as I mentioned, is driving to 2026 with standards and guidance material procedures for full integration in IFR airspace.
Yes, good question. To the first question, why do we need to integrate? Well, we want to be at the forefront to understand and know what we need to integrate this in our airspace and how it impacts us and how we work this into the integration. It's coming. We cannot stop it. It's coming. We're in the Jetsons. So we need to be there at the forefront, and we need to figure it out together. We need to make sure that we're trained. Number one, we're safe. We need to make sure that the public feels that they're safe with legacy and with new entrants. Technology is great, and it's going to keep evolving. So when we start to figure this out, we're going to have to figure out the next evolving new entrant, right? And so hopefully working through this process and working together with the testing, because testing is extremely important to help us understand how to build those operational requirements, but also those airspace requirements, and they are integrated together, airspace and operations. So we've got to figure that out together and work to getting those new entrants in. And to the ICAO, I'm in a lot of those ICAO discussions now on the integration. We're trying to figure that out. Most of the other countries are, working from the ground down, where we're working from the ground up. We're going to meet in the middle somewhere someday with all our math problems and acquisition situations and so forth. We are going to get there. I'm confident in that. But yeah, it's just important for us to work together to get to that end and understand how we need to make those standards, not only for us, but for the operators in the airspace, so that we can do it safely and efficiently and then have the right training.
Trish, if I could just speak to commercial space for a moment, because it's a new user that, you could say exploded on the scene into the, but it's been amazing. I think there were 39 in 2018 launches, and this year there's projected to be something like 108. So it is a dramatically expanding area. The impact has been pretty extreme in any given day, depending on the weather patterns. And what we've seen with the commercial space industry is we've seen them beginning to understand that there is a need to look at their impact if they want to have success and continue doing launches. And a lot of their launches are payload launches out of the Cape, which have the most impact. So those are going to continue. A lot of those are in some way include something on behalf of the government. So there is a collaborative decision-making process that has been, they've had 2 meetings now. Right now, they're just meeting with the commercial space industry. We're a part of it. but they're going to start to meet with the traditional users of the system probably sometime next year. So that's an example of how a new user is starting to kind of make fledglings. As far as the FAA is concerned, the agency did time-based launch procedures where they were trying to tighten down the amount of time that airspace was closed. And there have been some tools that are being designed and implemented. Right now, they're just at the Commercial Space Command Center in Warrenton, Virginia. But the ultimate goal is to be able to give the controllers the information that they need on the glass for facilities where launches are taking place. I mentioned that it was a way that you had this combination of a recognition of impact by the user community, if you will, embracing of certain ways in which the traditional aviation community has managed operations, as well as the FAA, both procedurally as well as new technology has engaged. And so there, I think, are some positive examples that could apply as we look at both UAS and AAM.
It does remind me a little bit about the ADS-B mandate for January 2020 for GA users and the giant pushback for that mandate. And now it's made the system safer and you couldn't take it away if you wanted to. I think GA pilots love looking at their flight and seeing everybody else in the sky. Let's go to the first question here. Do the terminal airspace classifications BCD systems, designs, and requirements need to be modernized for these new technologies? And that's probably for you, Wendy and Jimmy. And I'll add on to that question. Do you see us seeing not just adjusting airspace, but new flight rules?
So I definitely see possibly new flight rules. We haven't really had any discussions on changing the Class B, C, D airspace. I'm not going to rule it out. I think possibly in discovery we may find that we need to do something going down that road. At this time, we don't have plans to do that, but.
Yeah, so it takes so long to change an airspace. I think anybody in here who's ever tried to get their Class B or anything changed knows it's not something that happens overnight. And I think the industry does not want to wait for an airspace redesign to happen before they could go fly. I think it would be something in the future as we see these operations scale up and we see the interaction between the current users, I won't say traditional legacy, current users and new entrants. Maybe it will, we will redesign some stuff to see what works out best for everybody. New technologies, but I think we would all like new technologies for the most part, and some of the stuff, and I think it's going to work depending on how I think maybe more the UAS side of the world than the AAM, because I think AAM, especially starting off, a lot of them, not all, but most, there's a pilot in there with the radio and all that stuff. We kind of have that technology now to get them in there, but I think that's kind of where I'm sitting at with that.
Yeah, if you look at the current air traffic control paradigm, we say safe, expeditious, and orderly flow in that order, and the reason for that is the evolution of air traffic control from 1956. It was shrimp boats and paper-based, then radar, then trajectory-based, which is where we are, infocentric NAS, FAA is going towards that, and then levels of automation that will be distinct to try to support the ATC folks to get that scale. Fundamental question is, can we make things more dynamic? Your question about classification of airspace is really, that's a structure. Class B airspace, in a way, it's a structure. You have to have certain equipage, otherwise you can't enter, right? So it offers a structure. Can we do a more scale-free, structure-free airspace that is more dynamic? That's likely in the long future. Research has to show that, that's possible. What are the fundamental requirements on that? You can have Class B turn into something else if the traffic density and the type of aircraft that are operating there changes over a period of time. Right now it works because the type of operations that happen in Class B are very homogeneous. But if that starts to change over throughout the day, maybe that's a different way of looking at it. So it's really demand-based, how we get to that point, and can we optimize all three things? Air traffic controllers do a fantastic job. Safety is the first priority.
Thank you.
Efficiency and orderly nature, right? So how do we get to say if the efficiency becomes important, sustainability and the level of scalability is now order of magnitude different, you want to still maintain the safety at the same level and inject the scalability and inject the orderly flow and optimize all of them simultaneously, then we had to relook at it. What tools are necessary? What automation is necessary to support the functions? So, and what is the fundamental role of humans? How do they still be managing that, and there is a evolution from here to there. It's a really fascinating topic. I mean, ATC has evolved from 1956 and will continue to evolve at the pace based on the needs and the technology and so on.
And I think that was said over and over again on the previous panel, that they're not going to just be here a million new aircraft in the system overnight. It's going to be an evolution. It's just a matter of how slow of an evolution is it going to be? And I don't know, what do you see, Wendy? Do you see, I kept hearing that the skies are big and there's a lot of space up there. I don't actually agree with that. I think the skies are very crowded.
I think the skies are very crowded too. I agree with you. I think we're getting away from the big sky theory because there's so many aircraft in the airspace, and we've actually grown with legacy aircraft coming out of the pandemic and so forth in several different areas, because I think they anticipated that we weren't going to come back until 2024. Well, they were wrong. And here we are. And then we have all of the new entrants coming in. Class G, we do have activity going on in Class G as well. It's not just clear. We have planes there, and we have all kinds of other things going on within that airspace. So it's not a big sky theory any longer.
Yeah, another panel, and I hate to keep referring to it, talked about the sand shifting when the traffic came back, brought up Austin and other places. This is also going to shift the sands a bit. Now you're going to have vertiports out away from airports or on airport, both places, out in the suburbs. A lot of use in Class G airspace, which gets to our second question here, is I routinely fly jets into and out of non-towered airports. Do we know what I can expect around these airports when on advisory frequency? Well, that's our today scenario right now with Lance and UTM. What's happening now and affecting those Class G airports?
So we do have several industry folks that are looking at that particular area and how to maneuver around that area. I think much like an advisory frequency, we may be looking for an advisory automation type system where we know what's around them, and the UASs flying in the area know where there's other UASs or other aircraft. I think that's some of the technology that they're really looking at, just for awareness pieces and advisory pieces, much like we do with the advisory frequency, right? Mm-hmm. Kind of the same mantra, I think, is the thought there, because in a lot of those areas we don't have the surveillance really that we need to see everything or know everything from an air traffic perspective. We have some smart companies out there and some smart people, so I think we're going to see some change within that area as well. So, Jimmy, what do you think? Or I'm sorry, Andy.
Well, Trish, if I could, so let's just talk about UAS now. The use case is going to really drive what you need. So if you're patrolling or reviewing a pipeline or an electrical grid or something like railroad, I mean that is not going to really impact. But if you're doing package delivery, where do people live? They live in metro areas. That's where you want to do it. Right now, and I'm way oversimplifying this and maybe rounding off a whole bunch of edges, but the FAA's approach to the UAS has been to say, you come up with your own means of controlling your operation from an air traffic standpoint in a particular area. And the FAA really needs to make sure that that doesn't get out of hand, that there are standards for that and some requirements, because otherwise what we're going to end up with is different component pieces that are in the NAS or attempting to be in the NAS that may not be really meeting the same kind of requirements. So that's something, as this matures, that I think it's going to really need some attention. And I don't have like the answer as to how you resolve that, but some sort of requirements around it are going to really be key.
Jimmy, you have.
Yeah, no, I agree completely with you. I think right now, if industry's trying to reach out in some facilities on both sides, not just UAS, but AAM, hey, what can we do at this one place? What can we do at this one place? That's not a national strategy. And if these industries want to progress and be successful and grow, there does need to be a national strategy. And I think that is the job of the agency. And I'm not saying that the agency is doing what they can with what they have right now. I would argue that we probably need to do more, and we need more resources to be able to do this. But I couldn't agree more that we cannot have just different things all around the country. It's never going to work. It's not sustainable. I couldn't imagine trying to be an operator. Okay, what zip code am I in today? Oh, I have to fly at 250 feet here. That's not going to work, and it's not going to work for air traffic to try and think, okay, at this, how many satellite airports do some of our large TRACONs have? Could you imagine trying to figure out what different satellite airport is different? I mean, there's all these other things we already, and then do it by company, not even airport. How many, 3 companies there, 3 different procedures? That's not sustainable.
Yeah, and to that point, so back to my statement when PK was talking about testing, and I went back to testing, and I think that's where we're going to get some of that standardization, Andy, because I agree, we don't want one-offs out there. We want it to be able to work within our NAS that we have today, or be integrated in our NAS today. Yeah. With the systems that we have currently, possibly, but if we need to do acquisition for further automation or systems, that's something we are looking at as well. But I think that and from an FAA perspective, we do want standardizations. We have lessons learned when we have the one-offs within the NAS system, so, yeah.
So as controllers, Jimmy and Wendy, we have plan A, plan B, plan C, right? Because we prepare ourselves for things, sequencing not working, separation, equipment going out. So let's talk about failures of new technologies and how do we deal with those? I mean, there's several questions. What type of backup do we have? If the ground to aircraft signal fails, the command and control. These are all communications, but as I mentioned earlier, we're really talking about command and control, not just communications. So what have you discussed these technologies, not just with that they need to do this, but what are the backup plans when they fail? What are the contingencies?
I think we've had that conversation a few times.
Have we? I wasn't there that day.
You weren't there that day? Did you forget? We've had the conversations. There's so many different ways that these things react, or when they have a failure or when they have a lost link. It's kind of hard to get our minds around what do we do.
So it's interesting because when I first started this, they go lost link, and then someone would love to jump in. Lost link's just like Nordo. I go, absolutely not.
No.
Because Nordo, there's still a pilot on board, and then when you get to the airport, I get to shoot a nice bright light at you that tells you whether or not you can land or not. That doesn't really exist with UAS, right? If it switches over to a lost link and some programmer said, nope, you're landing runway 24 right, Elliot, okay, here we go. And there's no stopping it. So now where are the cutoffs? How long do I lose that piece of concrete? Because at some point, if I can't stop that UAS from coming in, I can't occupy the runway. Mm-hmm. I can't lock and load and go because I have it out. So there are a lot of different things that it comes. And then things fail. If it runs on, we all have computers, get the blue screen of death. Control-Alt-Delete. Are we hitting Control-Alt-Delete when the guy's at 40,000 feet? I don't know if that's the answer. I hope not. So these are a bunch of, these are the things that we're trying to look at. This is the type of stuff that keeps me up at night. The 2-pound drone flying at 10 feet at a farmer's field, cool. I hope you don't like hit a corn stalk. That's great. The larger stuff that's going to be at higher altitude, that's what we need to worry about.
Yeah, so what you are really highlighting, and all of you, is really need to assess contingencies and analyze different types of contingencies and solutions to address those contingencies so that we don't create problem for rest of the air traffic or airspace operations, right? So to be a good neighbor, share and care in the airspace, if you have a contingency, then how does that get addressed without impacting the whole bunch of, 911 type of contingency is different, that all land is a different scenario. But here we are one that has impact on many others, and this is the reason where people then debate, is the segregation better? Because then that say, if right now the drone rules are such that 5 miles from airport you can't go, because what happens, there is a flyaway and you're going to cause major impact to the airport operation. Right. We don't want that to happen. So when we are learning about these technologies and their reliability and their challenges, that's when we have these rules and regulations to say, oh, maybe we need to keep them separate for a while till we understand what it is, right? So that's sort of the way I'm thinking about it, it's really in our collective interest to come together and say, contingencies, what are the solutions for all these contingencies? And as a result, what can we allow, what can we not allow when they are coexisting? One example of the advanced eVTOLs, let's say battery-operated aircraft, and their battery life, let's say the range is about 45 minutes to 60 minutes. If you look at the conventional rule for helicopters and general aviation, that's you need to have 45 minutes of reserve fuel. Well, this is not practical to have reserve fuel for 45 minutes when you're doing battery aircraft. So what is this? The intent of that is different. The intent of that is not just the minutes, but that you are able to safely land somewhere and it does not cause a risk to passenger and the property. How do we go about doing that? Does that mean that along the way of your trajectory from 2 vertiports that are 45 minutes away, roughly, you have landing spots that have pre-programmed, pre-coordinated, that if you have a contingency, you'll go land there. Bird strike happens, battery depletes, whatever the reasons could be. But there are, what I would say is the regulations, the rules exist, procedures exist. We had to look at those and say, like, how would that characterization of that procedure contingency will manifest in the new operating paradigm, and what would it need to assure the safety of that operation, given that it's not practical to have 45 minutes of reserve fuel. So it's a sort of interesting way of looking at it, but that requires a lot of coordination. You guys know what contingencies you face every day. Like it says, every day is a training day. Yep. So you have that insight. Technologists want to figure out how to help with that. FAA wants to make sure that the system, information architecture, all of that hangs together and the operations sustain. So all of that, and the new entrants work very closely and nicely in a harmonized manner with the current users. So all of that, I think, is a really good, rich discussion. There's a lot more research to be done. I keep saying that I'm advocating for more research, but that's what we do. So it's a public service announcement. So.
And if I could add on the ultimate contingency on UAS, which is what we refer to as counter UAS. And that would be, what do you do when you have the drone? It may be still under someone's control, but all of a sudden it's in airspace near an airport. And the FAA has a process that they go through. TSA is the lead, other agencies get involved, but we're right now in the throes of having to get authority extended for the ability for that drone ultimately to be brought down if that's what it takes. So there is at least a recognition that you could have a drone appear that isn't supposed to be there, whether it's inadvertent or whether it's intentional or whether it's just, lost its homing device or whatever you want to call it.
Yeah, we do we do a lot of work on that. There's a whole line of business in the agency. Actually, one of them came with, because I wanted him to see what we do on this side, and then for controllers to be able to speak with them. And I think it did a lot of good this week. But that is definitely something that is being looked at, I think. And you're right, because as more and more of these coming in here, and then to speak to leaders, we call them the clueless and careless, right? Not everyone's out there to hurt you, but maybe their stupidity will hurt you. So we need something to stop that from happening, and that is definitely another this world, just the UAS world alone is so huge. When I started in 2 years, I'm like, and they're like, hey, we need a UAS rep for NATCA. I'm like, cool. So like people out there with their little DJIs all the time, I had no idea how big and what I got myself into. Thanks, Trish, Paul, and then Rich and Andrew for continuing to keep me here. But the counter, the mitigation, what the airspace looks like today, 5 years from now, 10 years from now, with the drones and how they're going to be integrated, we're going to look back at this panel and probably chuckle and go, that was what we were worried about. I think there might be something else that we don't even know yet.
Yeah, well, I've talked to you many times, Jimmy, because I did volunteer through IFACA at the ICAO RPAS panel, just to fill in for a little bit. And I've not been able to walk away because I feel like I really need to stay there, because we don't have enough air traffic controllers in these work groups having these conversations about what this is going to look like. And I know Jimmy and Will are both inundated with, you could be on a call every day, all day long about this subject and still miss hundreds of meetings. And it's so the point I want to make is we need more involvement internationally and in different countries.
Trish, can I ask you a question?
Yeah.
What does it look like when you're seeing things internationally? How is the U.S. comparing to the rest of the world?
Well, two different ways. So the U.S. is always looked at as a world leader in every meeting I've ever been, and they always want to know what's the FAA doing, and they want to follow suit. But the concern I have is that there are opportunities in other countries to do more testing. They are less regulated, and they can show a different kind of business case. So that's my plug for why we need to be involved, because if we're not, we're going to inherit what some other country has decided is the best way to do something. Now, maybe the FAA and NATCA will stand up and not do that, but there is that conversation that continues to happen. If you don't do it here, they'll do it somewhere else. So I think most would consider we're ahead of the world in this conversation. I would agree, yeah, I would say that we are. But I want to go to this, because this comes up a lot on the panel work. Our lost link procedure is going to be standardized so ATC knows what to expect. At the ICAO level, certainly there is work with developing lost C2 link procedures as one of them. And again, these are still in the work group level, and member states can take the recommendations or the standards or develop their own. They have that opportunity. But what's happening right now is they have some generic standardized procedures for lost C2 link. If you're within 35 miles from your destination airport, you go and land at that airport. If you're within 35 miles of your departure, you turn around and you go back. If you're en route, you have, and you go to your destination, or you have an indicated alternate in flight. However, there is always this caveat that the appropriate people should get in the room and develop appropriate procedures for the airspace that these aircraft are going to be flying in. And that would be the recommended thing, because there's never one size fits all. So generic procedures, I think, make sense if you don't develop your own, but I guess the push would be develop your own, because you can't, what would work in the New York area wouldn't work in, Texas, DFW area. It's completely different types of really busy airspace. But completely different. So Jimmy, I don't know at what level, I don't want to take the answer on the international level, but have you guys started talking about lost C2 link procedures, and are you down to that level yet?
So some of the stuff that's kind of the conversation where we're at right now, the work groups that I'm on, it's what parts can be generalized, right? If you're already at cruise altitude and whatnot, can we generalize that? Just keep flying your flight plan. But I think the closer you get in more congested airspace, you're getting closer to land or whatnot, just like you said, what's good for N90 is not going to be good for I-90. Where do we have that cutoff, right? Is it you hit the star and then depending on what airport you're landing at, that airport says, hey, all our UAS will come to this runway? I don't know. It could be that way. So, but my vote is to keep it as standardized as possible throughout the country, because that only lends to safer, it's easier to train, less room for mistakes. But it's the lost link thing, it really does keep me up at night.
The scariest part of it all, because
Yes.
it's not just the procedures. Yeah, the answer we get back when we say, well, what if, is it's going to fly itself. It's fine. Now it's autonomous. It's not going to fall out of the sky. It'll go to, stay on its flight plan. It'll go back to its departure airport. But when it goes back, we're still in does it now taxi off the runway? Does it stay on the runway? And the answer is we should leave it on the runway. Well, from us, okay, now you just close down that runway, which now you've impacted everybody else in the system. So a lot of conversations being had all over the world about this new technology and how it's going to impact those of us that have been in this system for a very long time. And I find it very interesting. You've mentioned training about 3 times, which we all know. Every day's a training day. It's important. I will tell you, I get a lot of kickback at the IK level that it's going to be so seamless that we won't even need to train air traffic controllers. They'll never even notice that it's going to happen. But yeah, we will. I promise you we will.
I'm not sure I agree with that one.
No, but
I'm with you on that one, Trish, for sure, yes.
let's see. Okay, that one got answered. Well, I'm going to go to one that I thought was very interesting. I know we're talking about integration from an air traffic controller's perspective and flight rules and airspace and procedures, but I think just the very fact of not having a pilot in the aircraft and all of the questions that brings, and I want to bring up this question that came up on the last panel. After hearing Tammy Jo explain how they felt the shuttering of the aircraft and how they use it to determine their actions, how is that replicated for aircraft without pilots on board? That decision-making capability that you have with a pilot on board, that now a pilot on the ground is, even through cameras, may not make the right and appropriate decisions for an aircraft in distress.
That's a good question.
I thought it was a really good question.
I think PK would be in the best position, having been
And I guess
involved in
that's
research.
the concern with artificial intelligence wherever we're looking at it, right?
Right.
Was once you remove the human and that adaptability in decision making that humans have, what are you sacrificing? Okay, you get automation, you might get more efficiency, but at what critical point are we sacrificing too much of human and let me give you an air traffic control perspective. If we become monitors because we have so many tools that make our job so easy, and we see this even now, even with pilots, and then things start to fail, are we going to be able to take over and fly the plane? I mean, we talked about in the last panel, the Joby airplane is going to be easier to fly than a traditional aircraft. Same with air traffic control. We monitor more planes in our sectors, and then the system fails, and now we have to start applying old school clearances and separation standards. What does that look like? What are we sacrificing?
Yeah, that's a really good question. All the human factors research has shown, Raja Parasuram, one of the famous, and then Tom Sheridan 50 years ago almost, that monitoring is not where you want to just put humans on that job, right? They need to, if you want them to save the day, they need to be actively involved. They need to have a mental model, the whole thing. So when we do that, then you basically are saying that they're actively involved, and when you're actively involved, then your workload is the one that drives basically how much you can handle. So this is the paradigm that happens when you want someone to be actively involved, and your workload dictates how much work can be basically processed, number of aircraft at a sector, as an example. So the premise of automation is that we will try to replicate the things that humans do. So hazard perception, in case of pilots, hazard perception, monitoring, processing of information that is shown on different displays to say what is the state of the aircraft, is it doing the right thing, is it going control, basically loss of control and this, that, and other. So lots of these functions that pilots do, controllers do. Can we faithfully automate them and say that we will have 100% reliable automation and it's going to continuously learning? If every day is a training day, then one and done automation will not work. One and done automation doesn't work because you're learning every day. New things come up and new things need to be mentally processed and they get part of your psyche and mindset to do the next day. How do you create that level of automation sophistication that meets the performance standard of 10 to the minus 9 or whatever have you of the safety and yet learning? And we really don't know the 100% answer to that question. How can we create a learning-based automation that is going to get us the same level of safety and the scalability that's postulated for future? And that is really, again, lots of formal methods, which is the mathematical processing research, the algorithms, the sensors, the perceptions, and all of that happen. Autonomous people try to compare with autonomous car. They say autonomous car can stop and wait for command from ground control station somewhere that's sitting in the Silicon Valley. We don't have that luxury, right? So how do we actually, can we get to that future? That's a fundamental question, and we really don't know answer with certainty.
So, Jimmy, did you have something you kind of were?
No,
Okay.
we started talking about autonomous cars. I mean, they've been testing autonomous cars that have actually hit people crossing the street. So, yeah, again,
Yeah.
back to autonomous. It's not always the one thing that's going to fix it.
So we had two on the last panel with their specific type of aircraft. And PK, you could probably answer this. We're really talking about all sizes, from 737 cargo, being remotely piloted, eventually maybe autonomous completely, to package delivery, and even some of those very, very small aircraft being integrated into the system. Whether they're integrated or they're on their own and going to and fly over, let's talk about the human factors on the other side of that. How do GA pilots, I mean, it's hard enough to see another Cessna in the sky. How do you see a very small drone in the sky? How does tower controllers, how do they see? I mean, they're better binoculars, I guess. I don't know the answer to this. So the other side of that equation, because we really are talking about all types, from very, very small to very, very large. And the human factors, are we at the FAA talking human factors yet? Certainly you're doing it at NASA, I would guess, as well, as you mentioned.
We are talking to human factors at the FAA. We have lots of conversations on all of the acronyms, UAS, AAM, UTM. Did I get them all?
I think so.
Okay. So human factors is going to be a big part of that as well. And how do we separate from all of these new entrants? What does that look like? From the small ones, from FedEx, Amazon, whoever's wanting to come into the airspace, to the big Boeing 737s. That's part of the crawl piece as well. So, and that's where the testing comes into play as well, to see where we need to put systems in place and where we need to build those operational requirements and standardizations that we need to do in the future. Again, that's where we are in that crawl space.
Yeah, the tower piece, when you're talking about, was it look a tower person being able to see a drone and whatnot, that's definitely one of the things when drones moving on the movement areas, right? The runways, taxiways, all this stuff, that's our responsibility. And then it's one thing to have an F-150 going down the runway doing a FOD check. It's another thing having a little drone this big going, like, what tower controllers will be able to see that, right? So what can we do to help our controllers out, or what do we have, lack of a better term, a non-radar procedure for our tower folks to be able to get these things onto the moving areas? I mean, it's all the different stuff that we're trying to look at right now. There's just so much to go from 60,000 feet all the way down to a taxiway. That is what this is really trying to do, just on the drone world. So when we talk about synthesizing these new entrants, I mean, that is literally, we are talking from the ground to the heavens, and that is such a huge, huge thing to do.
Yeah.
So, and human factors play a part in every single piece of that across every type of facility.
I mean, it was mentioned on the previous panel, the cluttering of the scopes. You have so many targets. Are you going to what are we going to do as controllers? I mean,
I might have been in a meeting one time where I said what you call clutter, I call traffic. So,
that's a good point.
yeah, so, because that is another thing that we're worried about.
Yeah.
So,
But there is a fundamental limitation of human brain, as superhumans as the controllers are, particularly Jimmy here, right? But there is, there's a limit to which information can be processed by humans, and that is where, it's an interesting thing. How do we show that information that is most relevant for air traffic controllers to act on it? You want to show everything, that's one. Then it will just figuring out what is important, what is not. So that's sort of that's what the human factors things.
yeah, because you don't want to be inundated with too much information, right? Yeah. What do I need to be able to do my job?
Trish, in the FAA's approach to the UAS community, low altitude, it was remote ID, which is a system that there's an identification means for the drones. And the FAA specifically said that ADS-B requirements, the ADS-B could not be used. So that would be for a low altitude application. Let's just say, it's out of controlled airspace. The idea of controlled airspace use by a UAS out of the Aviation Rulemaking Committee that had specific recommendations around this was that UAS would have the capability to essentially squawk and talk and be able to respond to controller instructions. So those were kind of laying out as the standard parameters. So maybe in kind of, it's basically a simplistic response to your question, but I would say that the expectation would not be for small UAS outside of controlled airspace that the controllers would have to have a role in that. But obviously for UAS in controlled airspace, it would be an absolute requirement. Jimmy?
No, you're good. Okay. Well, let's talk about communicate. We're out of time. We'll get to it. There's a lot of questions there. I still have 6 pages of questions here, and I'm going to do this. Jimmy is the NATCA UAS rep, and if you have questions, and I'm sure you do because it looks like it, I would go to Jimmy and get answers to your questions and talk to your leadership teams, your RVPs, and your safety and tech director, and get involved. Pay attention. It's coming, and there's a lot of unanswered questions. There's a lot of things already being discussed at every level in every country, and we need subject matter experts involved to get this addressed, all of these things, and there's a multitude of them. Like I said, it could be every day, all day, and you still wouldn't be able to keep up. So there are more people involved, the better. So thank you for listening so intently to our conversation. I know we barely scratched the surface, but I appreciate everybody listening and your time and look forward to your questions. And thank you to our panelists, Andy, PK, Jimmy, and Wendy, for your insightful contribution to the conversation. And I know that we're all in this together as far as #1 priority is safety, safety, safety. So thanks again, and we look forward to the conversation later. Thank you.